Hello and welcome to the DSP Leaders Summit on 5G Evolution. I'm Guy Daniels, Director of Content at Telecom TV, and coming up now is our Solutions and Strategies Roundtable, where we'll be getting to the heart of the matter, so to speak, and discussing the 5G core. Standalone 5G core systems are being deployed and put to work, but what does this mean for the way service providers run their networks? And how does this change the way that services can be developed and marketed? Is 5G network slicing about to become a reality, for example? Well, let's find out what our guests think, and I am delighted to introduce Miguel Carames, who is Director of Network and Technology Planning at Verizon, Chris Simcoe, who is Director Network Applications Architecture at BT, Patrik, Rokyta, who is Vice President Systems Architecture at NetNumber, and Dave Bolan, Research Director with the Dell'Oro Group. Hello everyone, good to see you all. Thank you very much for taking part in our roundtable. Now, we asked our audience what they regarded as the main issues around 5G core, and from their feedback, we've created a series of key questions. So let's begin with the first one, and that is, what does the new 5G core offer that makes it better and an essential upgrade to the existing LTE EPC? Miguel, perhaps I could start by asking you about that one.
Yeah, thanks, guys. So when we look at the differences between the 5G core and the legacy 4G core, the EPC, we are looking at two main aspects. So more tactically, we're achieving a much lower cost per sub and cost per gigabit per second, right? And this is critical to the business. And then when we look strategically at what we are enabling, standalone core allows us to move workloads around the network so we can achieve some flexibility when launching new services or moving the workloads that are involved in supporting, for example, mobile edge compute like ultra low latencies. So these are the main benefits that we are looking for in the 5G core when compared to EPC, is the flexibility and a lower cost point.
Thanks, Miguel. Chris, there's a lot of interest around 5G core at the moment. Is that the key? The fact that it's more flexible than what we have currently enjoyed?
Yeah, absolutely. The flexibility, I think, goes deep. The way that Miguel was saying about allowing the core to be distributed around the network, but it's more than just for specific user services. I would look at it as kind of changing the topology of how a mobile network's deployed. It's really allowed us to optimize the overall network and embedding it deep into our fixed network at BT as well. So combining the fixed scale that we have with the new flexibility of the mobile core. The other thing that it's done is it's been a complete technology refresh. So it's just enabled new capabilities from an operational point of view that we wouldn't have had before. And then going forward in helping pave the way for the new services that we're going to be deploying in the future.
Thanks very much, Chris. And Patrik, can you give us the vendor perspective on what makes the 5G core different from what's gone before?
So, in a nutshell, 5G core shall deliver more and faster data, but the difference and the benefits also come from the way how the 5G core is implemented and from its deployment model. For the sake of simplicity, the virtualization that we have experienced with the 4G core is not necessarily needed with 5G because the 5G is basically built on cloud-native technology, and there are a cloud-native ecosystem, namely Kubernetes, that can orchestrate a high amount of containerized workload. So by building the 5G core as a set of smaller software units that are easily moved between the suppliers and the operators, completely different aspects can be brought to automated deployment and lifecycle management compared to the EPC.
Thanks, Patrik. And Dave, we've heard from two operators and a vendor about what the 5G core offers. What are you seeing, looking wider at the whole telecoms market here? What are you seeing that makes 5G core an essential upgrade?
Well, one thing is the 5G core is inherently more secure than the EPC network. So that's built into the standards. And then the network slicing, it was alluded to, but that allows the operators to custom tailor the service level agreement that they might want to have, for instance, with an enterprise. And I think that's one of the big bright spots that everyone's looking at, being able to serve the enterprise with new capabilities that was not possible in the EPC, especially with edge computing, to have the lower latency, and even putting it on premise to help provide those services to the enterprise network. So that's the huge, big opportunity to expand the revenue base beyond the mobile broadband networks that customers that have been traditionally served in the 4G era.
Great, thanks, Dave. Well, thanks everyone for those answers. I think we should move on to our next audience question, and we move from the technology to what the technology delivers. And Chris, the mission is all about delivering the services. So what new solutions and services will the 5G core enable? How will it help operators?
I think it's interesting, kind of referring to what Dave was just saying. I think what the 5G core has done for us is actually enable a discussion in the marketplace to really look deeply at what I would say is how we help enterprise customers really make use of mobile technology. So although the 5G core will bring things to us, such as the ability to distribute the core, to make things like edge computing scale, there's lots of private networks out there today that are being deployed with 4G, with edge compute. And I think the whole 5G discussion has just really turned us to really think more deeply about embedding mobile technology into our enterprise customers and what that can do for them. So don't get me wrong, the 5G technology will help to enhance these services, tune them, optimize them, make them better, but we're not sitting around waiting for it. A lot of the things we've been hypothesizing about what we can do with 5G, we're actually starting to do now.
And Dave, you just mentioned earlier the importance of the enterprise here with 5G core, and Chris has done exactly the same. So is this a key strength of the 5G core when it comes to what new services and solutions will be enabled?
Well, Chris is right. 4G has been doing a lot of private networking already. But as we look forward into the 3GPP standards, there's more capability that will become available when we get into time-sensitive networking. That gives the potential of replacing Ethernet with 5G and 5G LAN that is coming up in the standards. And those are going to be extremely low latency networks, have to be synchronized. And those are some new potentials that aren't being addressed today as the technology becomes available, as the 3GPP standard evolves. And those are some of the things that people are looking at longer term.
And Miguel, what about you? Are you saying that you're seeing the same types of new services and solutions that we've just discussed, or any other ones there we're overlooking?
Yeah, so I agree with both Dave and Chris, a big opportunity on the enterprise side. And I actually like how Chris was positioning. So it's the same, like we are bringing solutions to market today on EPC and non-standalone as well. We do believe that we get a level of, again, like flexibility, functionality, and new features with standalone that kind of takes it to the next level. A lot on the enterprise side, a lot of opportunities also on the public safety and government and first responders, right, where slicing becomes a very powerful tool to offer some of those differentiated services to, again, first responders, tactical networks, and so on. But then there will be, and there are opportunities on the consumer side that we cannot overlook, right? So some are paired with mobile edge compute, and some will be with the evolution of slicing from, the early days, there will be more, a little bit simpler evolution of existing services to a future where slices will be created on a dynamic fashions to serve particular needs in very specific geographies and times of the day, like say big events and venues and so on. So we are excited about the opportunities on the consumer side as well. Although obviously, when you look at the early opportunities for increased revenue, a lot of them are on the enterprise side.
Sure, yeah. Thanks, Miguel. And Patrik, what's your perspective from the vendor perspective on what new solutions and services that the 5G core could enable?
So from the supplier perspective, and also by looking at the 3GPP, you basically have some of the services outlined by the default assignment of the network slices to the 5G services. So we mainly talk about a group of 5G services, which is the enhanced mobile broadband for the residential market. That is the ultra reliable low latency communication for latency critical application. That is the massive IoT. It's also the fixed wireless access. I would like to hear how this resonates across the operators that want to create a market share across households that are cable or wireline connected. And it's the vehicle-to-vehicle communication. Those are the 5G core services by definition. But you can basically, by using the network slicing, you can run any 5G service with its specific characteristics, let it be QoS, out of the same physical infrastructure. And even enterprises or industry facility, even outposts can be basically configured or provisioned as a network slice within the 5G core network. So that gives the flexibility to the operator to basically utilize always the same physical infrastructure and also the distributed infrastructure in case latency is the key, and build the services as a logical layer by utilizing the network slices.
Okay, well, thanks everyone. Unless anybody else wants to come back with some more comments on this one. Miguel, were you looking to?
Yeah, so maybe just quickly on since Patrik asked for the fixed wireless access. So I think it maybe the reason why we didn't really touch on fixed wireless access earlier is because so much of it is being done today, right? So we've been selling our 5G home product for a couple of years now in the NSA architecture. So there is a convenience and there is a improved use of the spectrum in standalone, and so definitely part of our roadmap. And we are very bullish on the fixed wireless access opportunity. We think there is a market there where multi-tenant units and so on. It's at times hard to retrofit cable or fiber, and fixed wireless access brings an opportunity to bring that service to market fast with an experience and a performance that's really comparable to what you can get from cable and fiber. So definitely a big market opportunity in the US.
Thanks, Miguel. And Chris, did you want to come in on the fixed wireless access angle?
Yeah, I mean, part of the fixed wireless access, if you think about what we were saying up front about the efficiency of the 5G core, one thing for fixed wireless or fixed access, the amount of throughput and the performance expected usually far exceeds what you deliver from a mobile service. And one thing the 5G core does is allows us to deliver at higher throughput service, but lower latency, but also at a more efficient cost base. So what I would say, the 5G core isn't a one-size-fits-all core. So whether you call it slicing up parts of the core or just looking at deploying the user plane closer to the users differently for a fixed wireless access type of use case, you can optimize the core differently for your different use cases in a way that was much more challenging with a 4G core. So yeah, we do fixed wireless access today with 4G, but also with 5G, but deploying it in the future, we'll be able to tune it and optimize it differently for FWA and other use cases we want to deliver. If you consider things like high touch use cases versus low touch use cases, partitioning the core in that sort of in virtual instances for the different use cases will allow us to deliver those more optimally for each case.
Thanks, Chris. But we've talked about what makes 5G core special. We talked about some of the services and solutions, but how does an operator actually get there? And this is the third question that our audience has put to us, and that is, what is the best strategy for migrating to a 5G core, 5G standalone core for an existing operator? And how long should this period take? Should it be instant? Should it be gradual? Dave, are you seeing any strategies emerging here about how we go about this migration?
Well, I think there's a couple things that has to be considered for an operator before they move to the 5G core, 5G standalone, and that may have to deal, and it's going to be different for each operator depending on their spectrum allocations that they have available to them. Because I think the least thing that you would want to do is introduce 5G standalone in a spectrum where you don't have at least the equivalent, if not better, spectrum or more bandwidth available than the 4G network. You want to see the consumer or the enterprise see better service, better bandwidth than they saw in the 4G world. So you want to make sure that that you have the right spectrum allocation available to exceed the performance of the 4G network. That's my opinion. We'll have to see what the operators say that are on the call with us here. That's, and then timing, it will depend on when maybe they got more spectrum coming. And I'm sure this is very complex. It's not easy to do, so it will take time. The migration probably takes a 1 to 2 year planning cycle, and I'm sure BT and Verizon are well into that planning stage already.
Well, let's put it to them, shall we, Dave? Miguel, if I could ask you first, what's your thoughts about how to best migrate to 5G core?
Yeah, so we are taking an approach in which we separate a little bit the mode of operation from the build of the core itself, right? So we look at the 5G core as a platform, as our directional platform where we want all our 5G customers to be and be served out of this core and evolve this core and the services to serve both non-standalone and standalone both. Right, so that's the build out for us. So we kind of remove some of the dependencies to Dave's point on when the certain spectrum is deployed in a given market or when you are ready to launch standalone services such. We can serve non-standalone traffic on our 5G core, right? And so we put kind of our development dollars on the 5G core ASAP. That's our strategy. So effectively building this dual mode core that will serve all our 5G traffic. The EPC or the 4G core is still very important for us for a number of services that really do not require 5G immediately. Think about some of the IoT offering, NB-IoT, Cat M1 that we have and we support and where we have a lot of growth. So it's an asset, right? We've invested in this asset, it's available to us. And now we have this flexibility to decide for a given use case based on the performance characteristics of that use case or that service, is it better served by the capacity that we have built on the 4G core? Or since it's more 5G centric, we'll place it on the 5G core, whether it ends up using non-standalone mode of operation or standalone mode of operation. So kind of allows us to have that flexibility, build a core without having to necessarily tie it to the mode of operation.
And Patrik, what are your thoughts about the best way to migrate? And how can operators achieve a high degree of interoperability between the 5G core products of different suppliers?
Yeah, I think it really does some of what Dave said. In terms of a standalone 5G core, I think it very much is tied to spectrum allocations, but also device availability and also device refresh. So when do we expect customers to refresh their 4G devices so they move on to 5G devices, whether that's non-standalone or standalone devices. So there are many, many different factors tied up with the migration to 5G standalone. However, similar to what Miguel was saying, we're taking an approach of having a single core that's going to support 4G NSA and 5G SA as well. So our intent is to migrate all customers onto that single core, and various ways to cut that for different operators depending on the approach. Some are deploying 5G SA overlays. Some are rolling out more widespread NSA. I mean, for us, just looking at different customer groups, things like enterprise customers versus consumer customers, the different services, and looking at the speed of migration of each customer type and how we can bring them onto the new 5G core, but supporting all of our existing services as well.
Thanks, Chris. And Patrik, any thoughts on migration? And perhaps I could rejig this question for you from the supplier side, and that is, how can operators achieve the interoperability they need between 5G core products, from the likes of you and other suppliers?
Yeah, this is really an interesting question, and I would also tend to say that it depends on a use case. It's different when you want to span a network across a outpost, industry facility, oil field, or a mine. If you have the terminals and you need some kind of surveillance with HD video, you can directly opt for a 5G air interface and maybe 5G standalone network. So where maybe mobility is not required, the decision might be quite straightforward. In my opinion, it's more about the requirements for the mobility, like residential users. They want to have higher throughput and maybe low latency, and they are on the move, and we don't want to tell the residential users to freeze in case they are in the middle of a kind of critical financial transaction they do over the data network, or if they do financial transaction on a moving train. So in my opinion, when it comes to mobility, then we must really ensure, whether it's standalone, non-standalone mode, that the session continuity must be guaranteed to simply have the same acceptance and service experience when using the 5G core as the people have with the LTE networks. And whether you now do it with two standalone cores, 4G or 5G, or with a standalone core connected to 4G and 5G air interfaces in this dual connectivity case, these two options definitely exist. It must be mentioned that Converged core is more suitable for operators that don't have 4G EPC, and operators that do have 4G EPC and want to somehow reuse it in conjunction with the 5G standalone core. They need to touch the 4G EPC and bring in all the interworking that is defined for the 4G, between the 4G and 5G core, for the session continuity. And it might be even problematic to go back to the EPC and start touching all the existing components just to enable them to interact with the 5G core. And yet another aspect, to be honest, is to harmonize the subscriber data provisioning and management across the two-generation networks. So in the end, you can make it technically possible with two separated cores, but the operation may no longer be cost effective. So this needs to be considered.
Well, let's move on to our next viewer question. This is a very interesting one. We've got a lot of interest at the moment around Open RAN, and we've got a number of our viewers are asking about, will we see a similar kind of movement or philosophy towards open core? Where the standardized virtual RAN was opened up by operators, they give them more innovation, more choice, and lower cost. Might we see the same thing happening in 5G core? And I know there's a few open source projects that delve into various aspects of this already, but I wonder if any of our guests have any thoughts about whether we might see a more sustained movement towards an open core, and if so, why, and do we actually need one? Anybody want to venture an opinion on that? Miguel, thank you.
Yeah, so when I look, to be honest, the core has been pretty open for years, right? And credit goes to all the work that's done in 3PP, where all the interfaces are defined, and really the framework is mostly existing as far as being able to bring the best in breed for the different network functions that comprise the core, right? Like 4G or 5G. We've gone with that approach, selecting best in breed from the beginning, right? Like, so it was the case in the all 3G network, definitely the case in the 4G and in the 5G core. So we feel like we have quite a bit of openness on the core as is, right? And it doesn't come without complexity. Obviously, any operator that operates in that multi-vendor environment, and at times with different suppliers for the same network function to kind of create the internal competition, knows that there is a functional parity exercise that has to take place, and there is a lot of interoperability testing that we need to facilitate or then run in our own labs and test environments. But I think most of the openness has been there, right? Like, and so when I look at the open core efforts, I do think there is a place for them more in like private networks and so on, right? Which is where they seem to be being tested currently. And so there might be a place there. We usually like to create the ecosystem with the vendors that we think do the best in developing a particular network function, and then get that ecosystem, build the functionality, right, and build a feature funnel for years to come. The downside when you are with one of these open source is, first of all, how do you're taking on some work, making sure that the code that you get from the open source programs is sanitized and tested, and it does everything that you want. And then you have to contribute some code as well. So some of the value that you get from your suppliers goes away, or you assume is going to be provided by the community, but it's not for free. Like you have to get more engaged and almost have to become your own supplier. So I see an opportunity for it for some specific deployments, as I said, like maybe private and such. But I think when I look at the like public networks, the micro networks, we still like selecting the best in breed from the suppliers and piecing together the what we think are the best pieces to create the best network.
Thanks, Miguel. That's really interesting. Chris, do you think we have sufficient openness in the core, or do you think these open core ideas and initiatives are more suitable to private networks, as Miguel was saying?
I think we do have openness in the core, like Miguel was saying. I think we're conflating two things here, potentially open source software and open interfaces. So the 3GPP core has always been very open in terms of the interfaces. I think, ironically, if you look at the lessons maybe we learned from the days of trying to deploy IMSs, and when IMS was first constructed with all the 3GPP acronyms and labels of interfaces between them, a lot of operators tried to deploy separate CSCFs from application servers from various bits and pieces. And I think over a period of a few generations of IMS, many realized, and most vendors would start coming to you and say, well, actually, it's very complicated to integrate, so you want to buy all the functions from me, which kind of works against the whole openness principle. But Open RAN is doing something very different. It's splitting apart the RAN and defining interfaces for that disaggregation. That disaggregation already exists in the 5G core. I think there may be open source projects that will have their place. A lot of Open RAN isn't necessarily open source either. So, both will have open source, but I think the important thing is, choosing, where you want to have different vendors or suppliers on either end of those interfaces. Even if it's not open source, having multiple suppliers in there requires a significant amount of integration to do, especially with things on moving your mobile core to a cloud native environment. There's various other vendors involved in the whole cloud stack as well.
Thanks, Chris. And it's always good to differentiate here and make it clear that we've got open interfaces and we've got open source projects, and things like the Open RAN initiative is all about the interfaces. If there's no other comments on this question, why don't we move on swiftly to Patrik, please?
Yeah. So I simply want to echo what Chris said. I also believe that the problem in the RAN area was different. In the RAN, we saw a lot of monolithic implementations that created some kind of vendor lock-in for the operators, and therefore the Open RAN focus was more on defining an open architecture, decomposing the monoliths into these radio, central, and distributed unit, and that allowing multiple vendors to create this best-of-breed radio access network, and also by basically offsetting the the central units from the radio units over distance over several 100 kilometers. And in a 5G core, we don't have such a situation. The 5G architecture is perfectly defined. The interoperability is described over open API specs, so multiple vendors can create interoperable product just with the help of the 3GPP standards. And therefore, when it comes to open core, and now we need to distinguish, as it was already outlined, whether it's open source or open architecture. The architecture we do have, that's open enough. And the open source, I don't know, there are many requirements for the sanity, security, regulatory. And in the end, open source will make sense when all stakeholders that are involved in that activity benefit from it. And currently the question is whether we see these benefits or not. And last but not least, it's not just functionality that needs to be delivered into the 5G core. The 5G core introduces a new deployment stack that spans from infrastructure over container services, platform services, into the network services and OSS. And it's not just about delivering the software unit. Yeah, that's probably the easier part. Yeah, the real challenge, in my opinion, will be how the operators will manage to orchestrate multiple vendors on the infrastructure of their choice. Yeah? If they give them just virtualization layer, then they may end up with multiple Kubernetes clusters, each from one vendor they integrate with. If they give them Kubernetes clusters, then they still may face a different set of platform services that may even clash with each others. And in the end, it also comes to how successful the OSS integration will be with all these deliverables into the 5G core network. Again, in the end, we want to build economic networks. It's just not about writing a new code.
Sure. Well, thanks everybody. Just time for a final question, and we've touched on this one earlier in the discussion. But Dave, let me start by putting this one to you. Do we need a common converged core that supports both 4G and 5G? And if we do, what are the benefits?
Yeah, I think all the vendors are offering that capability that provide a 5G core that it can interwork with the 4G core and even the 2 and 3G cores for people that still will have some legacy units. And the benefits that are being touted is basically the economies of operation in only having one core to manage and operate, and actually maybe even extend some services to those other customers that are still on the older technologies that they might be able to extend with the common core. So it's really, I think, an economy of operations, and but that's taking aside what's it take to integrate that and make that happen on an implementation basis. But I think once it's implemented, it's going to much be easier for the operators to maintain, and just having one core to maintain and operate.
Thank you, Dave. Perhaps we could just ask our other guests as well quickly for this same one. Chris, is the common core the way to go?
It definitely is for us. I think it kind of relates to the previous question, actually, about the open interfaces, ironically, in that having a common 4G non-standalone and standalone core, as well as 2G, 3G, there's a lot of interworking to be done there, a lot of interoperability, handovers, there's a lot of signaling. If you actually do that in a common core, as much as you want to support the open interfaces where you need to externally, internally, there's probably a lot of vendor-specific implementations that can optimize that for you if you have a common core. Even just think of a common user plane that is, UPF and user plane for EPC in one, rather than having separation of that. For us, that just makes sense, as well as just having one mobile core stack eventually to manage, rather than multiple core stacks for different generations.
Sure, yeah, thanks, Chris. Patrik, there might be a lot of work involved to do this, but is the common core the way to go because the economic advantages will outweigh the work, the difficulty, the challenges?
So for us, it's probably, for the suppliers, it will probably better to just build a converged 5G core with dual connectivity, because as Chris said, this interworking, session continuity, subscriber data management, harmonization is a lot of work in order to make two standalone cores to interwork. Converged core with dual connectivity is definitely the best choice. By the way, the Open Core initiative has Converged core as its vision for the activities. From the supplier side, we just don't face a single operator and a single network strategy. So unfortunately, the suppliers, they must be ready for any kind of evolution, whether it's interworking between two standalone cores or whether it's a converged core. But definitely, I'm happy to hear the opinion on the converged core, and I'm also somehow excited that the operator wanna basically harmonize all services around one converged core, bringing voice, text over NAS, IMS, over the converged core to the users over two different air interfaces. Because LTE has been out there for, let's say, a decade, And now it looks like with the Converged core, the lifespan of the LTE may cease pretty quickly, unexpectedly. But yeah, it's definitely a important message to us suppliers, even we may need to deal with different evolution plans of different operators.
Great. And Miguel, final thoughts to you. Is the time now right for a harmonized common core?
Yeah, so I agree with the comments from the my fellow panelists here. So there are some use cases where maybe a like standalone core that only supports a standalone mode of operation may make sense. I think it was mentioned earlier, some private deployments, maybe even fixed wireless access. But when we think about kind of like the macro network, the mobility, EMBB-like use cases, we want to put the customer at the center of the technical decisions and make sure that we are providing the best possible experience. And then a set of services that apply no matter what the radio access technology. And I think the Converged core is the way to accomplish that.
Great. We're all harmonized over the harmonized core. That's a great place to end our discussion. Thank you all very much for participating in the roundtable and sharing your views and opinions. Now, if you're watching this on day one of our DSP Leaders Summit on 5G evolution, then don't forget, please send us any questions you have on this subject and we'll try and answer them in our live after show program that's later today. And do take part in our online poll. You'll find it below this video player window next to the Q&A app. All of today's programs are available to view online here at Telecom TV, and we'll be back tomorrow with more roundtable discussions for you. Until then, thank you for watching and goodbye.